All right, let's look at calculating the z-score for the sampling distribution of the mean. So remember that the mean of the sampling distribution of the mean approximates the population mean, and the standard deviation of the sampling distribution of the mean is equal to the population standard deviation divided by the square root of our sample sizes, okay, the square root of n. Then if we wanted to calculate a z-score for the sampling distribution of the mean, then we're going to use this formula. And this looks very much like when we had the z-score earlier in previous chapters. So instead of an individual bear weight, now we've got the mean of a sample of bear weights. And instead of just population mean, actually we still have population mean. And then down here we've got population standard deviation, and we still have population standard deviation. But now the population standard deviation down here in the denominator has to be divided by the square root of n. And so what you'll notice by this relationship is that the spread of the sampling distribution of the mean is going to be smaller than the spread of the population itself. So this picture kind of shows that relationship. So for example, if we were still looking at bear weights, and let's see here, what would be, I was using a sample size of 30. Let's say we had, instead of collecting 30 bears, we collected 25 in each location. Okay, that was our sample size. And let's say the standard deviation for the weight of bears in the population was 30 pounds. So the standard deviation for the weight of all bears in California would look something like this, where it would be relatively wide and spread out. And so now if we were to calculate standard deviation for the sampling distribution of the mean, this is, remember, the distribution of all the sample means, that's going to be equal to the population standard deviation divided by the square root of n. And so this is going to be 30 divided by the square root of 25, which would be 30 divided by 5. And so this is going to be equal to 6. So notice that 6 is smaller than 30. This is wider, and the standard deviation of our sampling distribution of means is narrower. And that's what this graph, this curve represents. This is narrower because this is the standard deviation for the sampling distribution of the means. And this is wider, more spread out, because this curve represents the standard deviation of our population. Okay. It normally helps, this is very abstract and this is new. It really helps to see some examples. Okay, but let's stop here and let me know if you have any questions.